Hi guys, so this is our first Algebra 3 lesson. It's going to be a little longer than I would typically like to have, but since it's in video form where you can stop it, I am just going to go ahead and do the whole thing. It's about 14 slides, so normally I probably would have done 7 on Friday, and then we would have quit. You could have tried a few on your own and had done the rest of it on Monday and let you work on it the rest of the day Monday and probably Tuesday. Instead, I'm just going to push out the whole video, and depending on how long it takes, and I'll let you know at the end, probably say that you have 2 days to watch the video before you even have to start the practice problems. So what we're going to do for the first few lessons is a chapter overview from the Algebra 2 text. So from the video with the syllabus, I mentioned that we'll work out of Algebra 2, Pre-Calculus, and Math 150 textbooks. So this is out of the Algebra 2 text. We'll be going over Chapter 1 for a few days, the high points, and then Chapter 2, and then Chapter 3. So this is the stuff that you would see that I think is most important in Chapter 1, and I choose it because it's in college algebra. So you can see we're starting off with something kind of simple, or I hope you think so, and that is just simplifying a linear expression. So we're going to use the distributive property and adding like terms. So I'm going to take this 2 and multiply it across those parentheses. So we'll have 2x plus 2. Then I'll do the same thing with the -3, multiply it across the x minus 4. And then last, this negative in front of the parentheses, you could think of that as a -1 times the whole parenthesis. So everything inside the parenthesis gets negated. If it was a positive, it becomes a negative, and negative would become a positive. I will tell you, this is where I see a lot of mistakes, and it'll be throughout the course, the entire course. We'll have it in all kinds of things, in difference quotients and pre-calculus, which we also cover in here. But if you see a negative in front of a parenthesis, you have to change the sign of everything in that parenthesis. So now we'll add like terms. So we have those here with our x to the first powers. So 2x minus 3x is -1x, minus 1 more x is -2x. And I'll pause a little bit here sometimes to make sure I'm not making a careless mistake. When you all are sitting in here, I have the luxury of you all catching it and telling me I added something incorrectly. Now, if I don't catch it, I've got to start all over. So I'm trying to be more careful and also check as I go. So 2x minus 3x is -1x. Take away 1 more, we're at -2. And then for our constant, we have 2 plus 12 is 14, minus 2, we're back to 12. So -2x plus 12 would be our final simplified answer. I believe that was one entire section in Chapter 1. We're just going to look at that one problem. On to the next. So it's a completely different skill, solving linear equations. I'm not starting off with really simple ones. I'm already throwing some fractions in there. So the one on the left, and overall, when solving these, you're doing the opposite of PEMDAS, the order of operations, please excuse my dear Aunt Sally. We're using SADMAP. So we'll move anything added or subtracted first. So like over here, that's going to be the 9. Then we'll move anything multiplied or divided. That'll be the 3/7. And if we had exponents in parentheses, we would do those last, but we don't have those yet. We'll have those later this semester. So for the one on the left, we're first going to subtract 9. So 15 minus 9 is 6. And then you can do one of 2 things. I like to multiply by the reciprocal. It's just more convenient and efficient, I think. But you can do this, but I'm going to erase it. You can divide by 3/7. Just make sure if you're doing that on a calculator, you have to use parentheses. So you could do that and you'll get the right answer. I find it easier for this problem, and it also pops up other places to multiply by the reciprocal. So we will multiply both sides by 7/3. Now in doing so, this 7/3 would divide out And then on the right, we could have 42 thirds, 6 times 7, or 6 over 3 is 2, 2 times 7 is 14. So there's a few little ways to do that if you like. You can divide by 3/7 and just put the 3/7 in parentheses, or you can multiply by the reciprocal. For the next problem. So this problem has fractions everywhere, and the reason I want to show you this one is to show you how you can eliminate fractions really quickly. If you were having to get a common denominator for this, to add all these together, your common denominator would be, and normally I would ask you and have somebody tell me, but your common denominator would be 12. So once you determine that, you can multiply the entire problem by 12. And what will happen is all of the fractions will cancel out. We would have 12 over 4 is 3, so we have 3x. Then this other 12 over 3 is 4, so we'll have 4. 12 times x is 12x. And then last, 12 times 1/6, or 12 over 6 is 2. So I find that super handy. My air just popped on, so I hope you can hear me okay, but I find that super handy, and immediately all of those fractions are gone. And so now you can just move the variables to one side and constants to the other. So I'm going to subtract 3x from both sides and add 2 to both sides. And then last, divide by 9 to get x by itself. Since 6/9 reduces, you would be responsible for realizing that reduces by 3. 3 goes into both 6 and 9. So the final answer is 2/3. So I'm just still getting used to teaching remotely. Normally at this point, I would have asked you guys all kinds of questions and kind of know how you're comprehending. I'd stop here and see if you have a question. If you're confused, you can go back and watch this again, or jot down a question that you have and call or email me or get in on a Zoom with me later, and I'll help you with it. Continuing, again, since this is a chapter 1 overview, we've got several little topics today. So the next section would have been solving for a variable. So we're going to look at a couple of different equations for that. The one on the left is the type we'll use the most because it's an equation of a straight line. So we'll be using this when we solve systems. We'll be using it several times throughout the course of the year, trying to get this thing solved for y. Then I'm choosing this one because it's a good type of ACT question, and you see this other places where you have to solve formulas for certain variables. But starting with the one on the left, we're going to solve for y. So that means we want to move any term that doesn't have a y in it. So since that 4x is positive, we're going to subtract 4x. And I'm going to put it out front since we're used to seeing it there. Now we need to divide everything, and so this whole side gets divided by 9. So now we just have y. And I'm going to divide the -4 by 9 and the 30 by 9. And I do want you to separate those because now it's in slope-intercept form. If we were graphing this, or if you needed to know the slope for the y-intercept or a slope that was perpendicular to it, you can now look at that. Some of these do sometimes reduce, including that 30 over 9 reduces by 3. So I'm dividing the 30 and the 9 by 3. So now if you needed to, you could put it on your graphing calculator and graph it. You could compare its slope to another line's slope to know if one was steeper or flatter. But that's another place where you might be asked to do some things like this. So I'm also thinking about like the ACT and other places you see these questions. For the one on the right, we've got a volume formula that you may recognize from geometry, and we're going to solve it for h. Well, since everything is getting multiplied, we can really just divide. But I'm gonna start with just the pi r squared, and we're gonna deal with that 1/3 like we did the fractions on the previous screen. So right now, I'm just gonna divide both sides by pi r squared. So on the left, that was divided by pi r squared. On the right, of course, the pi and the r squared would cancel out, and we have 1/3 h. So I still need to remove the 1/3. Like the previous screen where we had those fractions, I want to multiply by the reciprocal. I want to multiply by 3. So I would need to multiply this side by 3 also. So in doing that, on the left now, I have 3b, and still that pi r squared. On the right, the 1/3 and the 3 cancel out, and we've now solved for h. And I guess it's back on. Okay, all right. Solve the All right, guys, I had to pause because the party music was on and all that stuff, so now we're back to everything. Thank you. So there's been like a 10-minute gap between I finished this one and starting this next one. So now we're gonna look at inequalities and absolute value inequalities. So starting with the one on the left, this is gonna be similar to the linear equations though, that's why it goes in the same chapter. So the one on the left, solving for y, we'll first start by adding 8 and then dividing by 5. Now we are going to graph and we're also going to write our answer in interval notation because depending on where you're answering this question on the ACT, you might have to match it to a graph. In college algebra, we use interval notation, so we're going to look at all 3 of those. So there's the inequality. The graph, I'm not really picky about these. You can just put the number we're concerned about, one number to the left, one number to the right, and then because it's less than or equal to 4, we'll fill in the circle here, and then for less than, shade to the left. If it was strictly less than 4 but not equal, we would leave the circle open. And then for interval notation, less than or equal to 4 means it can go all the way up to and include 4. So we're using a bracket as opposed to a parenthesis. So a parenthesis would indicate that we wouldn't include the 4. A bracket shows that we do include 4. And then it goes forever to the left, which is negative infinity. And infinities always get parentheses. I'm going to be doing several of these. So if you've kind of forgotten about interval notation, you'll hear me talk about it with several examples. So all 3 of these are ways to communicate what values of y are acceptable. The top one is an inequality. The middle is a simple graph. And the bottom one is interval notation. The one on the right is a compound inequality, meaning that there's 2 inequalities. And we're going to solve it like we did the one on the left, except like when we add 8, we're going to add it to all 3 pieces. And so then we have 6, the 8 added out, and then 18. Now we'll divide everything by -3. So we have -2. And because we divided by a negative, we've got to flip the sign. Again, we divided by a negative, we've got to flip the sign. And then 18 divided by -3 is -6. Remember, if you multiply by a negative, you also flip the sign. Now, if you look here, you'll notice that this is no longer least to greatest. So we're going to have to flip this thing entirely around. So we're going to have the -6 on the left and the -2 on the right, so that it's going smaller to larger. -6 is smaller than -2. And then t is in the middle. And you also end up flipping the signs. So if you'll notice, the inequality was pointing to that -6. It's still pointing to the -6. Or if you're looking at the -2, the inequality was open to the -2. It's still open to the -2. You won't have to do that too often, but when you do, you need to know how to rewrite it. Here, it was not least to greatest. Now it is. These are both less than symbols. So when we read from left to right, we want to read least to greatest. So there's two inequalities. This one is just a plain old linear one. And then the one on the right is a compound inequality. Continuing, we've got some inequalities now mixed in with parentheses, and we're going to have some different types of answers too. So we want to remove parentheses first so that we can move things around and add like terms. And then now you might subtract 4 or subtract 2x. I'm going to subtract 3. And it doesn't matter. You can move any one of 4 things. We just need to get our variables on one side and constants on the other. So I'll have 2x plus 1. And then next I'll subtract 2x. So I get 1 is greater than 0. So this looks funky. All of the variables have added out. So what do you do here? Well, you look at the statement, you decide is it true or false? Well, this one's true. 1 is greater than 0. So since it's true, now that's not the answer. We're just determining that that's a true statement. Since it's true, we'll say that all real numbers or all reals or infinitely many solutions are our solution. In other words, I could plug in any number for x and work out the left and work out the right, and I would get a true statement. So we solved this problem. We did all this work down through here. The variables added out. And since we were left with a true statement, that means that we have infinitely many solutions or all reals. If we had a false statement, which is probably what's going to happen on the right, I can't remember exactly what I had up here, but we would say no solution. I bet that's what's going on over here. So let's look at this one on the right. Let's start by adding 2 to both sides. And now we'll subtract x from both sides. And so again, the variable is added out, and we have 9 is less than 0. That is not true. 9 is more than 0. So this is false. False isn't the answer. False is just what we need to decide about that statement. Since it's false, we will say no solution. Sometimes you might see an empty set symbol that looks like that. It's not a 0. So those two are very different. You can't tell at the beginning, they look perfectly normal right here, but when you go to solve them, you realize like it's kind of funky. So you have to decide, okay, is that a true or false statement? If it's true, it's all reals. If it's false, no solutions. Next, these are out of the Math 150 textbook. It's something that they'll be doing in a couple weeks actually, but it is a linear inequality. It's just got fractions. Well, we're going to do the same thing we did a few slides ago, and that's get rid of all those fractions in one quick step. So you want to determine the least common multiple of 4, 3, and 4. Or in other words, if you were getting a common denominator, what would that number be? So in this case, it would be 12. So we want to multiply 3 by 12. So on the left, we have x plus 3. But 12 over 4 will be 3. Greater than or equal to, we've got that x minus 2. But 12 over 3 would be 4. And then last, 12 times a fourth, or 12 divided by 4, is 3. So it's similar to a problem we did earlier, solving a linear equation where we had a lot of fractions, but here it's an inequality. So like the other problem, we'll remove parentheses by distributing. And then combine like terms. So I'm going to, well, first I'm just going to add these two constants together, -8 plus 3. So that'll be -5. So now I'm going to subtract 3x and add 5. And since the variable's on the right, I do want to recopy it so that it's on the left, since we're used to reading left to right. And just make sure you keep it pointing to the x and opening to the 4. For us to practice one more time interval notation, for interval notation that would look like this. It can equal 14, so I'm using a bracket, or be less than 14, so forever to the left. Let's look at one more of these. If you want to skip this one, you can, but I wanted to do two since this one was a little different. So again, you would notice this is an inequality. There's fractions everywhere. It's really handy to be able to get rid of those. You'd want to determine the least common multiple of 2, 3, and 6. Well, that's going to be 6. So we'll multiply everything by 6. So I bring down the x minus 4. But 6 over 2 is 3. I'll bring down the x minus 2. Notice I need parentheses because I'm going to multiply it by something. 6 over 3 is 2. And I probably had some sign here. I don't remember what it was. I'm just going to make it a plus and cross my fingers. I don't know. And so then we'll have a plus 5. If it was a minus, it's no big deal. We'll just leave it. We'll go with this. So I'm going to distribute the 3 and the 2 and bring down the 5. Next, I'm going to do two things. I'm going to subtract 2x from here to the other side. So I just have 1x here. And I'm also going to go ahead and combine these two constants together, -4 plus 5. And then now I'll add 12. And so I have x is greater than or equal to 13. I'm going to pause here a second, let you glance at this. I know you can hit pause, but it's such a habit of stopping, letting you ask questions. Plus, I'm looking to make sure I didn't make any careless mistakes. And it looks okay. Interval notation will look like this. So x is greater than or equal to 13. So a bracket to show that it can equal 13. Remember, if it was strictly greater than, we would use a parenthesis. So we got a bracket, and then it's greater than, so forever to the right. If I ask you to graph it, I don't need a ton of numbers, just one number to the right, one number to the left, a filled-in circle, and then shaded to the right. Or instead of a filled-in circle, you could put a bracket here. I tend to use the circles, but a bracket there is okay too. Continuing, so now we're going to look at absolute value equations and inequalities. So these are on the ACT. They will be on your final in here. They're also a part of college algebra, so you'll see them repeatedly. So keep in mind absolute value. I would normally be asking you guys, but absolute value is always positive. And it is also distance from 0. So with this equation, since we have the absolute value of 2x minus 5, what is in here, this 2x minus 5, it's allowed to equal 9, but it can also equal negative 9. Because if this equals negative 9, the absolute value of negative 9 would also be 9. So whatever is inside is allowed to equal the positive or the negative of that number. It hasn't happened yet, but if there was stuff outside the absolute value bars, you have to move those first. So you have to isolate those absolute value bars. That'll happen later. So I need to solve each of these. So I'm going to add 5 and divide by 2. And then over here, I'll do the same thing. Add 5 and divide by 2. So we get 2 solutions, 7 and 2. You're welcome to write your answer like this. You may see sometimes a solution set in braces. You could express your answer this way also. I like to show you this because that's how it's displayed in the college algebra textbook. So when they're looking at the back of the book at the answers, that's how they'll see the answers. So this right here is a solution set, but you're also welcome to just list them separately like that. But we got 2 solutions. So that was an absolute value equation. Now we're going to look at some inequalities. We'll do a greater than or a less than. So again, absolute value is distance from 0. It's always positive. And this problem is saying that this must be more than 8 units from 0. In other words, it has to be outside the 8. So for this to be more than 8 units from 0, it could be outside the 8 to the right. So that's more than 8 units from 0. But if you think of a number line, it goes in 2 directions. This could be more than 8 units to the left. And so this would also be outside the 8. So this is to the right of 8, where this is to the left of negative 8. Both of those are outside the 8s. So now we would solve these 2 inequalities. So we'll add 2 and divide by 3. And you can just leave your answer 10/3. Here, oh, I made a mistake. Didn't I? Yeah, hold on. Let me go back. So here, we'll subtract 2 and divide by 3. Then over on the right side, we will subtract 2 and divide by 3. So we got 2 different sets of solutions there. X can either be more than 2, so like 2.1, 3, 10, 20, or it can be less than 10/3. As a decimal, that's about -3.3, so -4, -5, those would be okay solutions, but this would be how you would express your solution. So that was a greater than, and now we'll have a less than. So these colors are showing up really funky for my screen. So I am having to walk to my desktop to make sure that I'm picking ones that kind of match so that you can see okay. So here again, we have absolute value, it's distance from 0. This has to be within the 13s. It has to be less than 13 units from 0. I'm going to erase this in a second, but less than 13 units from 0. So inside the 13s. Well, that means I'm literally going to put it like that compound inequality we had a few screens ago, if you need to go back and look at it. I'm going to put this 11 minus 2x literally inside the 13s like that. So this is very different, looks very different from the previous one, all because just the inequality right here was split. So we solved a problem like this several slides ago. We want to isolate that x. So I'm going to start by subtracting 11. So negative 13 minus 11 will be negative 24. If we subtract 11 from the middle, that 11 will be gone. And then if we subtract 11 from the right, we'll have 2. Next, we need to divide by negative 2. So we'll have positive 12. I'm dividing by a negative. We did that earlier, so I gotta flip the sign. Dividing by a negative, gotta flip the sign. And 2 divided by negative 2 is negative 1. So x is now isolated, but it's not least to greatest. So I need to flip everything around. I need the smallest number on the left, the largest on the right, the x in the middle. And then now you'll have less than signs. But you can double check. If you'll notice, like the arrow is opening to the 12, it's opening to the 12 over here also. Or if you look at the symbol in between the x and the 1 right here, it's pointing to the negative 1. And it's pointing to the negative 1 here. Let me show you interval notation on that. So for interval notation, since it can equal the negative 1 and the 12, it would look like this, negative 1 to 12. If you had to graph it on a number line, some of these I'll have you graph, some of them I won't. You could just put those two numbers down. You don't need to make 100 tick marks in here and write in all kinds of numbers. That's unnecessary. So it's concerning 1 and 12. Then put a filled in circle or a bracket to show that it includes those endpoints, and then a shade in the middle. Some people like to do it off of the number line. If you were taught that way and you want to do this, that's fine. Some people do this with the brackets, that's fine. As long as you clearly communicate to me your answer, or able to pick it off of a multiple choice quizzes, tests, final, whatever, any is fine with me. So we've got the interval notation, and then last a graph. So that was absolute value, equations, and inequalities. We did a greater than and a less than. Next, we're going to just look at some that are just a little bit more complicated, that have a little bit going on outside the absolute value bars. So I mentioned a few slides ago that if there was something outside the absolute value bars, you'd have to move those first. Well, now that's happening. So we're going to start by adding 4. And then now, like we did earlier, you can either divide by negative 1/2, but I'm going to multiply by the reciprocal. To me, that's just so much more convenient. So over here, then these would cancel out, and the negative. So then on the right, I'll have just negative 8s. So I added 4, multiplied by negative 2. Now I have the absolute value bar isolated. So this is when I wish you were here and I could look at everybody and see if you can tell me what to do next, and people would start to tell me, oh, rewrite it and write this and this. One thing I mentioned at the beginning, absolute value is distance from 0, and it's always positive. So what do you notice here? That's a negative. By definition, absolute value cannot be negative. So what would you think the answer would be? If absolute value has to be positive, but this is saying the absolute value equals a negative, this will actually be a no solution. So you can't be a robot and say, oh, no, I write x plus 6 equals 8 and x plus 6 equals negative 8. If that was a positive number, if this 8 was positive, that would be true. But here we have a no solution. Next, then, this is the last example. This is new. This isn't, you haven't seen this, I don't think. It comes out of the college algebra textbook, not the Algebra 2. But it's not horribly complicated once you see what it looks like. We have 2 absolute values, so this clearly looks different than the others that we've had. Well, keep in mind, if we had like the absolute value of x equals 2, we would say, well, x equals 2 or x equals negative 2. So look at what we did there. We took this 2 and we left it the same, and we took the opposite of it. We're going to do the same thing, but with the 2x minus 5. So if you need to go back and watch my erasing, do so. We're going to operate on the same principle. So we're going to take this 4x plus 7 and equal 2x minus 5, or it can also equal the opposite of 2x minus 5. Right, a little space there. That's the key to this whole problem, is knowing that what is inside here, the signs don't matter. Like if this was 12 and this was negative 12, the absolute values are the same. If they were both negative, it's okay. So that's why we just need to take one of them. So I took the one on the left and I set it equal to the opposite of the one on the right. I did that right here. So now we'll solve both of these linear equations. So I'm going to start over here. I'm going to subtract 2x. And now I'm going to subtract 7 from both sides and divide by 2. I'm going to double check and make sure I copied everything correctly. So there's one of our solutions. Then the one on the right, I'll switch colors here. I'm going to distribute that negative. So notice that's a plus 5. Minus a negative is addition, or a negative times a negative is a positive. So I'm going to add 2x to both sides. And then subtract 7. And divide by 6. And reduce. So normally I'd be writing a little more slowly and asking you guys what we would get next, but you can pause and go back. I'm going back here to, again, make sure I copied everything correctly. Just you distribute that negative here, so that became a negative 2 and a positive 5. That's a place where there's common mistakes for sure. And then I added 2x, that got me here. And then subtracted 7, which got us here. And then divided by 6 and reduced. So we have two solutions. So our solution set would be negative 6 and negative 1/3 if we were looking at a set of numbers. I think that's it. Yeah, I know that's super long, so I have a feeling when I go look at the time, I'm going to let you work on this for a couple of days. I'm going to be posting pictures, separate pictures of every single one of these pages. Unfortunately, these first 3 lessons, it's kind of a hodgepodge. They're all over the place. Typically, your assignment will come from one page and one photo, but because we're doing chapter 1, you can see we're operating out of 5 sections and a few little problems out of the college algebra text. So I know these are a lot of problems, but I'm going to give you quite a while to work on this. So don't worry about a due date just yet. You're watching this on Friday probably. So I'm going to say you have Friday and Monday to watch the video. And then at least Tuesday and Wednesday, maybe even Thursday and Friday, since we have a Google Meet, to work on this. So when it's due, I'll let you know. It will be no earlier than Thursday. I won't push out a quizzes for you until Thursday or Friday, and then probably still give you a day or so to work on that quizzes. I'm going to run through the slides so that you can see the answers, but remember there's also going to be a PDF of this on my website so that you can look at them still. But here's the answers to 1.2. So those are all the distributive property and adding like terms. 1.3. 1.4. So this is where we solve for variables. Do get these in slope-intercept form because that might be useful to other things like putting it into a graphing calculator or comparing slopes if lines are parallel, stuff like that. Then here's 1.6. So you can see over here, I've got the inequality that you would have found. And then to the right, I graphed them on a number line. 1.7. So we're solving some absolute value equations where we're getting two answers for these equations. And then here we have any absolute value inequalities where you're getting a couple of different intervals that might be okay. And then last are the answers out of the college algebra textbook. These go in the order of the examples I work. So like the answer to this was one of the last examples that I worked out. I wish you were here and I could stop and ask questions. We would have really had this video over the course of 2, maybe even 3 days instead of all at once. So I'm going to be posting this. Today is Wednesday. I'm hoping I'm posting it today so you can watch it early if you like. But I want you to watch it and I'll write it on my website. Watch it Friday and Monday, and then don't even worry about starting the problems until Tuesday unless you want to. It's up to you. As always, contact me if you have any questions. You can call, email, and I'll talk to you on the phone or meet you in a Zoom or work out an example for you from the smartboard again if you'd like to see that.